In this video, we will discussing on Chapter 5, which is Life Cycle Interpretation, Reporting and Critical Review. The subtopic that we will cover in this chapter are Critical Review, Outlook, Illustration of the component using example of practices, which is using comparison based on impact indicator result, comparison based on normalisation result, and lastly is about sectoral analysis. Let's get started, which is the first part of this video, which about the critical review. So, what is actually critical review? Critical review is the process intended to ensure consistency between life cycle assessment and the principle and requirement of the international standard of the life cycle, which is ISO 14040 and ISO 14044. Previously, this critical review was called as peer review. Next is about the history of critical review. In 1993, a peer review of SCA study was proposed by the Society of Environmental Toxicology and Chemistry in a guideline, a code of practice. However, in 1997, the review process now called as a critical review is described in the framework standard ISO 14040. By an interactive accompanying review, there are two objectives should be achieved. The first objective is improvement in technical and scientific quality, while the second objective is to increase in reliability. There are three phases of peer review. First, at the beginning of the SCA, to review the goal, scope, boundaries and the data collection plan. Second, after initial data collection or modeling, this is to review the progress and offer advice or any comment. Third, at the final report stage, which is to review the adequacy of the study and the credibility of the conclusion. There are two types of critical review, which is Variant 1 and Variant 2. Variant 1 is critical review by internal and external experts. Variant 2, critical review by a panel of interested parties. Variant 1 is suited for internal study only, but not approved for comparative assertion to be made available to the public. If one, a critical review Variant 2 has to be accomplished. This figure shows the review triangle that consists of the review panel with the chair of the review panel, commissioner with the project coordinator, and lastly is practitioner with SCA project leader. Based on ISO 14040 section 7.3.3, an external independent expert should be selected by the original study commissioners to act as the chairperson of the review panel of at least 3 members. The chairperson should select other independent qualified reviewer. The panel can also include other interested parties affected by the conclusion drawn from SCA, such as government agency, non-governmental group, competitors and affected industries. A critical review by a panel of interested parties is mandatory if comparative assertions are included in the study. This is valid for competing product system on the market. Based on ISO 14044 section 4.2.3.7, if the study is intended to be used for comparative assertion intended to be disclosed to the public, interested parties should conduct this evaluation as a critical review. Based on the standard in ISO 14044 section 6.1, the critical review process should ensure that first, the method used to carry out the SCA are consistent with this international standard. Second, the method used to carry out the SCA are scientifically and technically valid. Third, the data used are appropriate and reasonable in relation to the goal of the study. Fourth, the interpretation reflects the limitation identified and the goal of the study. Lastly, critical review process should ensure that the study report is transparent and consistent. Technical specification ISO 14071 is to extend ISO 14044. The technical specification is to formulate some procedural aspects that need a better explanation of the critical review. This technical specification will give advice on how critical review should be properly performed and the requirement that reviewers and the panel chair should have. The ISO 14071 will support the use of ISO 14040 and ISO 14044 in other standards proposing a quality assurance for the base LCAs that may be used in these other life cycle methods as a solid basis. The next subtopic is 5.C, the illustration of the component interpretation using an example of practice by using the comparison based on impact indicator result, comparison based on normalisation result, and the sectoral analysis. First is comparison based on impact indicator result. The result of mandatory part of the impact assessment provides the data basis for this comparison. This illustration in this table shows significantly smaller indicator values within 6 of 8 regarded category for the investigated beverage carton compared to the PET bottle. The positive value indicate the value of beverage carton is larger than the one of the PET bottle, while the negative value is indicate the value of beverage carton is smaller than the one of the PET bottle. Second is comparison based on normalisation result. This graph shows the example of comparison based on normalisation result between the beverage carton and PET bottle. The normalized result of the product system for 1 liter beverage carton with closure and for 1 liter PET bottle in the market segment juice per hectare have already illustrated the usefulness of normalization. Third is sectoral analysis. In this example study, a sectoral analysis have been conducted and thoroughly discussed for all considered impact categories. The following text of example clarify the importance of finding consistent explanation for the environmental loads within the individual sectors. The example of study use example of beverage carton with closure system and PET bottle system. For the carton system, is dominated in all indicators by the production of the packaging material aluminum foil, polyethylene and beverage carton. In sum, these sectors contribute to approximately 50 to 70% of the system burden. Particularly high single contribution due to the production of plastic occur for the summer smoke and the fossil resources consumption which is greater than 13, as well as aluminium foil with acidification 30% and summer smoke which is 34%. The large relevance of the aluminium sector is the more remarkable as the mass contribution of this material to the primary packaging is amount only 5%. For the production of raw carton, it contributes to eutrophication which is greater than 20% and use 12% of fossil fuel and contribute to 41% of the entire cumulative energy demand. The energy content of the wood used for the raw carton production is accounted in the energy cumulative demand. For the production of closure sector, it contributes to 17% of fossil resources consumption. For other categories, contributions are between 7% and 8%. It also contributes to 20% for the aquatic eutrophication and land use for the forest area. Distribution is only relevant for the environmental category, which is terrestrial eutrophication, which the amount is 8%. For disposal and recycling sector of the carton system, it contributes for terrestrial eutrophication, which is 40%. It also contributes to the greenhouse effect, which is 23%. This sector takes account of emission from the incineration of the packaging material. PET bottle system. The production of bottle material was contribute to 47% of greenhouse effect. It also contributes to 79% of fossil resources consumption. The highest contribution is 19% in the category of aquatic eutrophication. More than half of this environmental effect is caused by the production of PA granulate despite its minor mass fraction. For the disposal and recycling sector, the lowest contribution for the fossil fuel consumption is 2% and the highest contribution is for the greenhouse effect, which is 29%. Now let's try to answer this question. The question is, if the studies are intended to be used for the comparative accession and to be disclosed to the public, who needs to conduct an evaluation as a critical review? Is it interested parties? Or external expert? The answer is interested parties. Thank you for spending your time to watch this video. Hope all of this information will help you to conduct the life cycle assessment study.